Hey, Loi. Thanks for making some time. I really appreciate it. I am very excited to talk to you today about Ingenuity, the helicopter that NASA's most recent Mars rover Perseverance carried with it across its 293-mile journey from Earth. I know I'm not alone when I say that watching Perseverance land almost 2 months ago now was inspiring in so many ways. And now we're getting ready to see the first powered flight on another planet. What some people don't know is that you were a part of making that a reality. So, can you tell me what was your role on the Ingenuity helicopter design team?
Yeah, so I worked with an external team. We worked with JPL NASA to, study whether it is feasible to fly on Mars. And back then, we just made a small model that, I had kind of from far away did a little bit of things regarding the wiring and how we power it. And after that, when we, like the project was actually interacted and we found that it is possible to fly on Mars. I worked on the development from early on. I was the electrical lead and power electronic lead from the external party, and I designed the inverter, servo motors, boards, worked on the selection of the servo motors, and actually worked on the electrical design part of the electric motor, and also like interface with all the wiring that actually go from the motor controller, because the motor controllers and the motor actually live outside of the hot box, the electronic box. That's actually the part that actually mainly was designed with from JPL. So, and then all the wiring that goes through and how you actually, you know, drive the inverters, and also worked on the inverter algorithm development in terms of how to control the motor.
Very cool. What was the biggest challenge of that effort, your portion of the design?
It is practically it's a mission impossible when we started. I mean, the idea to fly in 1% atmosphere, the thought of it was like kind of like it's not really possible. I mean, and based on the calculation, so the weight was really low. So the weight estimate that like go down to every single subsystem components. So and that's like, originally I had like this very hard goals of like to like design an inverter that weighed basically like nothing, like I think less than 5 grams, which was like I was like no way. So the other challenge is like to design for the environmental condition and for actually for the radiation, because you work in space, there's a lot of radiation, and to be able to handle the shock and vibe that happened during flight. So we had to consider all of these things.
What's different about the circuit design for that environment?
I mean, there's a lot of different things we have done, like in the circuit design. I mean, the main thing, honestly, is like, you have to really design things that operate at really like low temperature. The Mars atmosphere operate like it's like negative 120, negative 140. Some of the days it's already been reported. So like a lot of the electronics, because they use it for Earth, they actually operate at negative 40. So we actually had to design heater. So I had to come up with a very clever way to design heater that do not create a lot of weight. That actually embedded within the PCB boards. And you heat up the board to like negative 40, and then you actually be able to use earth-rated electronics. That just from that aspect, other than the radiation problems.
Interesting. You mentioned getting to partner with some of the members at JPL. I know a lot of engineers, myself included, have daydreamed from time to time about joining NASA or JPL. Can you pull the curtain back for us a little bit on that and tell us about your experience working with the team?
Honestly, I worked with a lot of smart people through my career. Some of the smartest people I worked with at JPL. I remember the first flight when we went into like the Mars atmosphere chamber, and that's the first time, we are able to actually test the software algorithm and with the motor, with the inverter. And, and it's like, it was kind of amazing just to see, like all the modeling we have done and all of that was able to fly on like basically from the first few times, so it's not like trying 10 prototypes to get to what do you want. Basically flew prototype 1.
Wow. And then you saw Mission Impossible, in real life color mid-February, right? What was it like for you to see Perseverance land on Mars?
The big day is still coming. The fact that the helicopter was able to communicate back to Earth, that most of the things are functional, like heaters, things like that. And that's really amazing. The fact that, like when you're going through the Mars atmosphere, that's like a lot of it's like 10 minutes of terror. It's like you're going through like, over 100 degrees C. Anything could have went wrong, and this thing just like, went to pieces. So all these like years of development and research and, just gone through the air, but, I mean, so that's a really big milestone. And, probably I'm really waiting. And another biggest milestone, actually, the legs are down. So I was worried about that. I don't know what people were, but.
Finally, I wanted to ask you what, from your experience working on the Ingenuity design project, have you carried with you that's impacted your future roles? Is there anything that you learned as a part of that team that you brought with you to your role as our Senior Director of the West Coast Tech Center?
Yeah, I mean, honestly, all through my career, I'm very, I like methodology of thinking about designing and like understanding things up front before you even like kind of involve in design. From place to place, that's different. So, working on this project, they actually work with a lot of people who like work the same way. So, which make you like basically, you hit the ground running. There is really no possibility to fail. I hope I can bring some of that into ATDI, and also there are other things like space radiation. How can you design for that? Because we do have some customer like work in similar environment, like, in medicals, like X-ray environment or radiation therapy, things like that, which is actually some of my direct customers. So a lot of time I have experience in working on things like that. Plus, we do have a lot of our aerospace customer we work with. So, some of that stuff actually does translate into that. In terms of like how to design, the lightest weight inverter or like, the highest power density in the world, I don't know if that's one of our goals.
Yet.
We have, I have that knowledge if we ever need it.
Yes. Already in place, ready to go. So for the next, Mission Impossible Mars project, we'll be ready to get it in. Well, thank you so much for your time. I know that you're a very busy man, but this has been very cool for me. And I appreciate you sharing your insights into what is a very cool project that we'll all be watching closely. And I'll be texting you for those behind the scenes updates. Just keep your phone around.
Oh, okay.